So yeah, everyone. So we are back at our study. So we have studied about the myoglobin and hemoglobin saturation with the oxygen pressure in our blood. So these are the some characteristics distinction between type A, type 2, type 3, sorry, type 2B fiber, and there is something type 2XT fiber. Fuck. Contraction time, of course, that's slow. Motor neuron, of course, they're small, and this is fast. Resistance to fatigue, this is high, this low, as we have studied. Activity, aerobic and aerobic, hours, 30 minutes, 1 minute. Okay, great. And mostly in cycling, running, this fiber is very important. Mostly in uh, sprints, weightlifting, this fiber is important. Then mitochondrial density, of course, we have studied. This is high because mitochondria deals with oxygen, but this is not. Okay. I don't know about this one. I have to study this. What is this one? Oxidate capacity, of course, low. Glycolytic are very highest because they need high glucose. What is sarcoplasm? The cytoplasm of muscle cells, sarcoplasm reticulum, the endoplasmic reticulum of muscle cells. That's where the calcium is stored. Yes. Tubule, the transfer investigation. Okay. Most of the I mean, क्या बोलते हैं, blood vessels, the transportation occur this way, right? But T tubules only transfers. I mean, this is present in this way. That is what T tubules is. So, that's this is Arcomore, the smallest contractile unit of muscle cell. Okay, A band, H band will study. So this is the complete anatomy of sarcomere. Sarcomere is the smallest unit of muscle fiber. This is the same pattern that every fiber follows, even the smooth muscle also. So there is Z line. Okay, the Z line mostly present in this way, like you can see here, like this way, and there is M line. Okay, which this line is called M line. The transverse line is called M line. Okay, now here the gap between the gap of thick filament is called A band. Okay, and from the end of the thick filament to the complete end of sarcomere, it's called A band. Okay, so that's what it is. So this is the thick filament which is in the middle. This is the thick filament. This is all the thin filament. Okay. Yeah, here you can see actually the waistline. Yeah, the H zone. This is the H zone. The M line, thick filament, also called thick filament को क्या कहते हैं? Myosin. The thick myosin, thin filament, also called actin. By the way, the biggest fact is that I mean myosin has also actin has also troponin, tropomyosin. People might get confused. Transverse filament. Transverse filament. Okay. Longitudinal filament. Titin and nebulum. Titin and nebulum. Where did? Okay. Titin and nebulum. Okay, we'll get into the complete detail of these filaments later. The muscle physiology also, this is very important. This is really important. We'll get to know very detail with ChatGPT like this way. First of all, there is action potential. We have to know what is a. First of all, there is motor neuron. Okay. First of all, motor neuron is a nerve cell that sends the present message from the brain to your muscle. Okay, from your brain to your muscle through the spinal cord. So when you say move your arms, there is certain action potential which is uh, formed from the neuron axon, and that action potential. How does that action potential formed? This is the step. So first this process occur, then this process. Remember it. So first, when we say that brain says, I need to lift my arm. So what happens is that some these neurons, thus with a motor neuron, they become positive. How did they become positive? Is that the sodium ions rush into the. That's why we say always, please drink electrolyte, no, otherwise you won't get energy, because that's how, because they are deal with this action potential. They deal with energy a lot. So when we say that we need to lift our hand, the sodium rushed in, and then the potassium rushed out. Then it becomes negative. The flipping charge gets a wave of electricity, and that wave of electricity form a action potential, and that action potential uh, you then go to the action terminal, the end of the motor neuron. And what happens is that action terminal is that they have a lot of. Let me actually show you the action terminal. This is really kind of understand. Okay, this is the action terminal. This is also called the norm terminal. Okay, so what happened is that the action potential went like this. Okay, then what happened is that the calcium ion entered the action terminal from outside the cell. Calcium ion entered the action terminal from outside. Yeah, of course. Because what happened is that this action potential triggers the calcium ion channel to open, like this is the calcium ion channel. Okay, by the way, these are the muscle. These are nothing to do with the synaptic. Okay, we will come to that all the point later. Okay, so this change in voltage, it causes voltage connected calcium channel to open. Calcium enters the from outside the cell. Then this calcium enter triggers vesicle controlling neurotransmitter called acetylcholine to release their content into the synaptic cleft. So this is called synaptic cleft. This is the in a space between the end of the muscle motor neuron, the nerve terminal, action terminal, and the muscle. They called synaptic cleft. Uh, uh, and acetylcholine is the kind of a chemical, which is a chemical. What is acetylcholine? It's a neurotransmitter. Okay, acetylcholine is a neurotransmitter that these vesicles have been storing themselves. As the calcium channel enter, this vesicle open, get release their content, and they get stored in synaptic cleft. And this process is called exocytosis. Okay, very important. And this acetylcholine diffuses across the synaptic glands and binds to the ACTV receptors. They don't actually receptors. These are the receptors. Okay, acetylcholine vesicle. I mean, they haven't shown a very good picture. Let me give you a very good picture. Acetylcholine. So after the acetylcholine releases, they get binds to the acetylcholine receptor, and then again some channel opens. Then the calcium, just like the calcium channel just got opened, the sodium rushed into the muscle fiber, making the inside more positive. Acha. Then again this flip flop member. Okay, sodium pin enter किया, then depolarization began to moxonata. So the moxa action potential wasn't actually happened. These were not actual motion potential. The electricity which formed from the change of charge in yeah, change of charge in. Oh, that was action potential. Then motion. Oh, action potential and motion potential, that different. Okay, we'll come to that. By the way, let me see some picture. Yeah, this picture will actually help us. You can see here, this vesicle, those are actually wasn't open till the action potential actually came, and the calcium channel opened. Those are actually wasn't open. Okay, then it got opened. Then it got actually it got opened. Then these are the receptor, by the way. Then it got open. They bind to the receptor. and this receptor actually again triggers some channel, I don't know. Then some channel triggers some sodium to enter. This sodium again created I don't know, muscle action potential. Then this muscle action potential quickly goes along the sarcolemma, the muscle cell membrane. Wow. It also goes deep inside the through the T tubules. Acha, 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 acha. Then this diagram would have, this is the T tubules, by the way. Okay. Mm-hmm. This sodium channel open. Okay, let's suppose this is the channel. This is the channel. This is the channel. Muscle potential travel quickly around the sarcolemma. Uh-huh. Okay. So this sarcolemma, sarcolemma electricity that is formed, okay, due to the acetylcholine receptor binds with the uh, neurotransmitter. Where bro? Acetylcholine binds with the neurotransmitter. There is action potential. This just went through this. By the way, this is the arrow you can see. This went through this at the door through this, and this actually does something. I don't know. They do something. Then you have to go detail, so that all the parts of the muscle actually contrast together. That is the thing. This action potential in the T tables activates special receptor called DHP receptors, which are connected to radars and September. Okay, storage bag for calcium inside the cell. Endoplasmic reticulum is the calcium inside the cell. Okay, this receptor open up calcium channel to channel. Okay, calcium ion are released into cytoplasm. Great, we know that. Calcium binds to protein called troponin, which moves another protein called We'll show a video. We cannot do that without animation video. We cannot ever do that. Guys, are you listening? Are you there? Of course. Is it recording? Okay.
Contraction coupling of skeletal muscle. Excitation contraction coupling is the sequence of events by which transmission of an action potential along the sarcolemma leads to sliding of myofilaments. The events at the neuromuscular junction set the stage for excitation contraction coupling by providing excitation. Transmission of an action potential along the sarcolemma leads to sliding of myofilaments. The events at the neuromuscular junction set the is a small space between neuron and muscle. Events by which transmission of an action potential along the sarcolemma leads to sliding of myofilaments.
When this fact was discussed, I don't understand when the bloody hell this fact was ever discussed. The sequence of events, transmission, action, potential along sarcolemma for sliding of myofilaments. What is myofilament? Okay, we'll understand this. Let's
The
have
events
patience.
at the neuromuscular junction set the stage for excitation contraction coupling by providing excitation. Released acetylcholine binds to receptor proteins on the sarcolemma and triggers an action potential in a muscle fiber. Action potential is propagated along the sarcolemma and down the T tubules. Transmission of action potential along the T tubules of the triads causes the voltage-sensitive tubule proteins to change shape. This shape change opens the calcium release channels in the terminal cisternae of the sarcoplasmic reticulum, allowing proteins T tubules of the triads causes the voltage-sensitive tubule proteins to change shape. This shape change opens the calcium release channels.
Where? Voltage sensitive something sodium gated channel for where?
Potential is propagated.
T tubule, they pass it through T tubules. These are the T tubules.
Down the T tubules.
Okay.
Transmission of action potential along the T tubules of the triads causes the voltage-sensitive tubule proteins to change shape. This shape change opens the calcium release channels in the terminal cisternae of the sarcoplasmic reticulum, allowing massive amounts of calcium to flow into the cytosol within 1 millisecond. Calcium binds to troponin and removes the blocking action of tropomyosin. When calcium binds, troponin changes shape, exposing the binding sites for myosin on the thin filaments.
Kid, does anyone ever got it? Does anyone got a single fucking movement of symbol? What the hell? Why have you said it, man? Troponin changes shape. Troponin. Okay, it's a thin filament. We'll watch it later. Keep watching again. Keep watching Appen if you want to understand. Keep fucking watching it.
Of calcium to flow into the cytosol within 1 millisecond. Calcium binds to troponin and removes the blocking action of tropomyosin. When calcium binds, troponin changes shape, exposing the binding sites for myosin.
Troponin, tropomyosin are the part of actin filament. Is it? Yes. Actin associated proteins, troponin, tropomyosin. Troponin has again three kind of protein. Let's continue with that. And my eyes are hurting. Let's use some knife. Knife.
On the thin filaments. Contraction begins.
Calcium binds
When
with
calcium
troponin.
binds, troponin changes shape,
And it is
exposing the binding sites for myosin on the thin filaments. Contraction begins. Myosin binding to
so these blues are troponin and these here are tropomyosin.
actin forms cross
Myosin myosin binds with tropomyosin. Pehand ka? Myosin from myosin binds with tropomyosin. Okay. Myosin from myosin filament binds with myosin.
bridges and contraction begins. At the action of tropomyosin. When calcium binds, troponin changes shape, exposing the binding sites for myosin on the thin filaments. Contraction begins. Myosin binding to actin forms cross bridges and contraction begins. At this point, the excitation-contraction coupling is over. Sliding filament theory. It is the most popular theory concerning muscle contraction. It was first
Sliding filament theory.
proposed by Hugh Huxley in 1954. It states that muscle contraction involving sliding movement of the thin filaments past the thick filaments. Sliding continues until the overlapping of the thin and thick filaments is complete. The changes in muscle during contraction are: the distance between the Z lines of the sarcomeres decreases, the I bands shorten, the A bands move closer together but do not diminish in length. The rows closer together but do not diminish.
This is contraction. Contraction means when the actin and myosin filaments are completely overlapped. Really? Do you see? No. Do you see actin and myosin filaments are completely overlapped? What is this? What is this? These are overlapped. Completely gap. Only myosin. No actin.
Diminish in length. The role of calcium in contraction mechanism. In a resting muscle cell, that is, in the absence of calcium ions, tropomyosin blocks or inhibits myosin binding sites on actin. When calcium ions are present, calcium binds to troponin, causing a conformational change in the troponin complex which causes tropomyosin to move, which opens or exposes the myosin binding sites on actin. This results in interaction between the active sites on actin and the heads of myosin. Cross-bridge cycling. When calcium ions are present, The myosin binding sites on actin are exposed. The ATP breaks down actin and the heads of myosin. Cross-bridge cycling.
This is important.
When calcium ions are present, the myosin binding sites on actin are exposed. The ATP breakdown provides
When calcium what? Calcium is always present. Calcium was always present, and the actin binds with the myosin part of the actin. Sorry, the myosin of the part of the myosin filament binds with the tropomyosin of the actin filament. Till that actually calcium was there. Then again calcium was there. क्या है ये?
binding sites on actin are exposed. The ATP breakdown cycling. When calcium ions are present, the myosin binding sites on actin are exposed.
Always
The
it has been
ATP
exposed.
breakdown provides energy to cock myosin head.
Cock myosin head. What do you mean by cock myosin head? FTP breakdown provide energy to cock myosin head. ATP breakdown provides energy to cock myosin. ATP breakdown of provide energy to cock myosin head. What do you mean by that? I don't get it. The myosin head is the part of the thick filament inside of cell. The myosin filament. That's like a little arm with a head that can grab active filament and pull it. But before it can pull it, it needs energy to bend back, like the pulling handle of a slide sword before releasing it. Before it can pull it, it needs energy to bend back. अच्छा अच्छा before pulling अच्छा because if you need energy अच्छा that bending back is called cooking. Okay, so what was the fact again? The myosin provides energy to cock the myosin head. ADP plus phosphate. Since when ADP start producing energy? When calcium allows myosin to attach to actin, the cocked head snaps forward, pulling the actin filament. That's the power stroke. Simple energy. Let's understand simple energy. You only pull back the string. This only take energy. When you press the trigger, it releases the stored energy. The actin moves forward. ATP breaks down for the energy go constant. With the myosin head ready, the potential energy to next level. Okay, that's how the. Acha.
The cocked myosin attaches to the exposed actin binding site. Cross-bridge attaches. Cross-bridge springs from the cocked position and pulls on the actin filament. The cross bridges break. An ATP binds to cross-bridge but is not yet broken down. The myosin heads are released from actin. As long as calcium ions are present, this continues until the muscle fiber is fully contracted. Relaxation. Acetylcholinesterase
This continues. Okay, the to cock to cock the myosin head, we need some energy. for that ATP binds, for that ATP breakdown. Okay.
ATP binds to cross-bridge springs from the cock position and pulls
Cross bridge springs from cock position to that is called cross bridge. Okay. And pulls
on
to
the
the actin
actin
filament.
filament.
So
The
they will keep pulling back till the overlapping occurs.
cross bridges break,
Complete contraction.
and ATP binds to cross-bridge but is not yet broken down. The myosin heads are released from actin. As long as calcium ions are present, this continues until the muscle fiber is fully contracted. Relaxation. Acetylcholinesterase is an enzyme present in the neuromuscular junction. It immediately destroys acetylcholine, so the motor end plate is no longer stimulated. Calcium ions are transported from sarcoplasm back into the sarcoplasmic reticulum. Linkages between actin and myosin are broken. The muscle fiber relaxes. Energy sources for contraction. The energy used to power the interaction between actin and myosin comes from ATP. ATP stored in skeletal muscle lasts only about 6 seconds. ATP must be regenerated continuously if contraction is to continue. There are 3 pathways in which ATP is regenerated: coupled reaction with creatinine phosphate, anaerobic cellular respiration, aerobic cellular respiration.
Sorry.
Coupled reaction with creatinine phosphate.
We'll come to that one. Somebody is texting. Please never open your WhatsApp. Yeah, hi, this is Bruno Kumar Samuel, and I'm sorry to say that your meeting has been cancelled. If you are Santosh, please say hi. If you are Santosh, please say hi. If you are Santosh, then please say hi. He said hi. uh, आशुतोष सैनी किसी ने बैंचनी लैब का असाइनमेंट किया है? व्हाट इज द असाइनमेंट? भाई तुझे पता होगा ना, मैंने बोला था सबमिट करने को। भाई तूने तो कंफर्म किया था सर से, आप दोनों में कुछ बात हुई? हमें क्या पता, सब थे क्लास में जब सर ने कहा था सबमिशन कब है। भाई पर तुमने ध्यान नहीं दिया, आप बताओ, मुझे याद नहीं। भाई ये मत करो, कोई स्क्रीनशॉट लेके इसलिए तो बहुत बुरा फंस जाओगे। Oh my god. So okay.
Between sources for contraction. The energy used to power the interaction between actin and myosin comes from ATP. ATP stored in skeletal muscle lasts only about 6 seconds. ATP must be regenerated continuously if contraction is to continue. There are 3 pathways in which ATP is regenerated: coupled reaction with creatinine phosphate, anaerobic cellular respiration, aerobic cellular respiration. Coupled reaction
Okay, anyway, sorry, I was distracted.
between actin and myosin are broken. The muscle fiber relaxes. Energy sources for contraction. The energy used to power the interaction between actin and myosin comes from ATP. ATP stored in skeletal muscle lasts only about 6 seconds. ATP must be regenerated continuously if contraction is to continue. There are 3 pathways in which ATP is regenerated: coupled reaction with creatinine phosphate, anaerobic cellular respiration, aerobic cellular respiration.
So these 3 are deal with the 3 type of muscle we have discussed. The aerobic muscle is type A, type 2, type 3. Creatine phosphate is very high required for those glycolytic type 2 phosphate They do really. That's why this muscle builder take creatine before doing heavy lifting.
Couple reaction with creatinine phosphate. Creatinine
That
phosphate plus ADP produces creatinine plus ATP. Muscle stores a lot of creatinine phosphate. This coupling reaction allows for about 10 seconds worth of ATP. Muscle
again,
fatigue.
sorry.
Reaction with creatinine phosphate. Creatinine phosphate plus ADP produces creatinine plus ATP. Muscle stores a lot of creatinine phosphate. This coupling reaction allows for about 10 seconds worth of ATP.
Acha.
Muscle fatigue. Muscle fatigue is a state of physiological inability to contract. If no oxygen is available in muscle cells to complete aerobic respiration, pyruvic acid is converted to lactic acid, which causes muscle fatigue and soreness.
This is kind of emotional and kind of funny both. Okay.
Muscle fatigue results from a relative deficit of ATP and accumulation of lactic acid. Oxygen debt. The oxygen debt is the amount of oxygen necessary to support the conversion of lactic acid to glycogen. This conversion is needed to replenish spent glycogen stores. Heat production. Almost half of the energy released during muscle contraction is lost to heat, which helps maintain our body temperature at 37 degrees Celsius. Excessive heat is lost through many negative feedback mechanisms, including sweating, dilation of superficial blood vessels, increased breathing rate, and increased heart rate.
So yeah, that was the part of the thing that we have actually discussed. It was actually very interesting. It was very much important that how the due to flexible potential causes contraction and have myosin head. Yeah, myosin head, actin filament, pacha, pacha, pacha. Like this one is pacha, pacha, pacha. This is a contraction of it. I don't know. I didn't actually pay attention about relaxation, but that was it. Ah, it was awesome, man. मजा लगा. So yeah, till that we'll make a next video. Let me give you a rest.